Hi everyone. In today's talk, we'll be addressing creating an open platform for equity trading at scale using analytics and deep learning as the tools for the underlying platform. The goal is to implement both a development and a production component of the system. In a production level trading, we care about too many aspects, not just the stock price. We care about high and low in the day, volume, which many primitive trading examples rely on. For example, the relationship between precious metals like gold and silver, availability of social media feeds, automatic analysis of analysis reports like SEC reports or earning calls, calculation of momentum, and cash valuation. In addition to this, we also have to comprehend the analysis with market indicators, volatility indices, as well as many other aspects that will have to get integrated into the model. This is the workflow of a single asset, whether being a stock or a metal or a commodity and so on. Sources and inputs to the system would include pricing, volume, media like videos and sound and news and text, tweets, Facebook, statuses, company financial data, in addition to historical data. Once sources are available, they are processed through stream processing, polling, and batch processing. Data will be explored, visualized, cleansed, and augmented and enriched. Once data is ready, we start building the model and we start validating this model. Finally, the model gets through cycles of testing until it's ready for deployment. That's when it's monitored for accuracy and performance post-deployment. In this slide, we're showing an example of developing production clusters. For example, on the development side, the TensorFlow model will be driving the training service based on long short-term memory to predict the price and volume of an asset. While in production, we'll be deploying this model at scale. To give a sense of the complexity of the trading floor, there are multiple types of trading desks. For example, equity trading desks would handle everything from equity trading to exotic options trading. Fixed income trading desk would handle government bonds, corporate bonds, and other bonds and bond-like instruments that pay a yield. Foreign exchange trading desks facilitate trading in currency pairs by acting as market makers. They can also engage in proprietary trading activities. Commodity trading desks are focused on agricultural products, metals, and other commodities such as crude oil, gold, and coffee. Each desk has multiple personas like brokers, hedgers, managers, risk managers, and so on. In our architecture, we have multiple clusters for each asset. So clusters for stocks, clusters for precious metals, another one for commodities, another one for indices, and so on. In this, we show the need for Kubernetes as our platform to handle all the complications surrounding the execution of the prediction service on a single asset. Really, the size of the box here is entailing the complexity as we captured it from Scully and others in their published reference at the bottom. But the idea simply here is there are a lot of other services and tasks and processes that go before and around and after the machine learning code is done. And being able to comprehend all of this is extremely important for the valid execution of the system. From a machine learning perspective, this is the machine learning path where the data gets ingested, analyzed, transformed, validated, you split it, you train the model, you build the model, you validate it, then you augment with the training at scale, you start rolling out the model and serving it, and then you monitor and log it. And we'll be talking about each stage in the coming few slides. For each asset, we'll always have to ensure that we're remembering that components of development and production, they have to be dealt with separately. so that you ensure the agility of the development while deployment at scale for production. As we said before, stocks are not the only asset. There are other assets that are extremely important with cross impacts across all of these components, like precious metals, commodities, and bonds. For multiple equities, for example, stocks, precious metals, we use more clusters for us to be able to comprehend and run this analysis in separation, since each one of them will have its own set of constraints and development and deployment different from the others. So being able to isolate them is extremely important to ensure the continuity of this work. Again, we're just getting you back to the machine learning path, just to keep in mind that not only you have to isolate the different commodity stocks and others, but you will have to ensure this process goes forward with every cluster you have in hand. The first path, which the data is ingested in and processed, for example, the ticker data are fed into the ticker processing pods, which in turn are ingested into a Cassandra interface pod. Similarly, the tweets are processed through pods which are later saved into the Cassandra database. We relied on already published libraries from Google, for example, like Click to Deploy. For the ease of managed services, the scalability is achieved through vertical put scaler, which actually helps us a lot that we don't have to worry about it since it's a managed service from a cloud provider. Data analysis segment is extremely important, and it's really the foundation of building what comes next in the model. So processed data are stored inside Cassandra, including Twitter analytics, which have their servers read the processed data and provide the analytics around it. Many R-based functions based on Shiny provided a predefined analysis. For development part, it is computed on Jupyter Notebook within the Kubeflow to provide direct analysis to the data stored inside Cassandra. Data scientists will use the Jupyter Hub notebook installed on the development cluster for data exploration, visualization, and analysis of processed and inference data that were stored in the Cassandra database. Many algorithms have been implemented on our platform, like correlation, momentum, market angles, ARIMA, MACD, and sentiment analysis, and all of them work directly on the Cassandra database. We use data flow where parallel execution of the algorithms to determine the best correlation and prediction. Here there are multiple services. One, the development service pods read ingested tweets, analyze the sentiment through communication with natural language processing parsers, and finally recording the analyzed tweets into Cassandra database. Data scientists test their algorithms through running Jupyter Hub and communicating with the sentiment analysis service. Another set of pods that generates correlation between two different stocks, gold and other stock. This is very useful in prediction of prices. Some of these filters are given here as examples in this list of filters that we'll be talking about. For example, an ARIMA filter, autoregressive integrated moving average on all stocks and testing them against actual return. For every filter, we run many parallel algorithms and tested the best possible outcome. From analysis of variance, ANOVA, we looked at the independent two-samples t-testing. For analysis of covariance, we looked at the covariance as the main driver, including predicted, marginal means, and linear prediction. Holt-Winter tests trends and seasonality in the data in hand, and being able to understand that is important for addressing the trending that is key for addressing the performance. Autoregressive moving average, ARMA, were also used for being able to understand the stock behavior. And now getting into the next part, as we're creating multiple sets of cron jobs, one to transform data into formats used by TensorFlow, another is to do the transformation. For example, PCA, whitening normalization, outliers, and so on. So being able to run the cron jobs is very important for us to be able to fork off these different tasks simultaneously. Here's an example where removing outliers, the cron job for data augmentation, PCA, principal component analysis, as well as whitening. When we move to the data splitting, this is where it fits in the machine learning path, which is extremely important before you start training your model, so that you will do this multiple times until you reach the converged or the consistent model that meets the desired workflow as well as expectation needs. Basically, the incoming data is split into training, validation, and testing data sets, and any changes in the data will re-trigger the rebuilding of the underlying components. Examples of splitting is actual splitting is more complicated than just dividing them, but it's extremely important to try different sets of the splitting that would result in directly influencing the model as we build it. And this part is executed using TensorFlow jobs, TFJobs, created on Kubeflow, where the long short-term memory LSTM for price prediction, the random forest models for asset market prediction, and the natural language processing analysis for the media and the tweets and textual information. Multiple simultaneous jobs are created and validated. Here is an example of a YAML project. The data was read from multiple data sets before we started working on them. After that, we extend the model on larger number of assets and different number of intervals, predictions within the last 5 minutes, 10 minutes, and so on. Yet another example here of YAML for the worker as we build the system up. Next idea is the hyperparameter optimization technique. Test for different parameters, making sure the sensitivity is within acceptable range, and then you start delivering onto the next steps for the buildup. Once the model has converged and settled, we start worrying about the rollout and the serving of these models at scale for it to be deployed. We use Seldon to serve the model, and we use Istio in correlation with Seldon to control the traffic. Kubeflow has been key in building the whole process and controlling it. We created container images for pre-processing, training, analysis, prediction, and deployment, and each deployment has been scaled independently. Thank you for your time. I hope this was of value to you, and looking forward to your questions. Thank you.